This is AS Chemistry Chapter 5, Lesson 2 on biofuels and carbon neutral. So let's start by talking about what a biofuel is. The definition of a biofuel is the following. A biofuel is a fuel produced from renewable living things such as plants. So I'll go through it again. The definition of a biofuel is a fuel produced from renewable living things such as plants. Plants can be grown again and again, so they are a renewable source. In contrast, fossil fuels, coal, oil and gas, took millions of years to form, and they are not renewable. So ethanol produced by fermentation is considered a biofuel. It's produced from renewable plant sources such as sugarcane. So sugarcane can be planted again and again. So ethanol produced by fermentation comes from plants, which are renewable. Ethanol can be burned and combusted to release energy. And ethanol produced by direct hydration of ethene comes from crude oil, which is non-renewable. So ethanol made by fermentation, since it's made from a plant source, which can be grown again and again, is considered to be a biofuel. And ethanol made by the hydration of ethene is not a biofuel. So let's look at ethanol as a biofuel. Usually ethanol is mixed with petrol in order for it to be used as a motor fuel. So ethanol isn't just used by itself neat in a car. It will be usually mixed with petrol in order for it to work. And here's an example. A fuel called bioethanol E85 contains 85% ethanol and 15% petrol. And what this does is it significantly reduces the amount of petrol that we're using, i.e. the amount of crude oil that we're actually using up, which is non-renewable. And by replacing it with ethanol, which is produced by fermentation, we're making what we call a biofuel. The only problem is that the engines of cars need to be modified in order for them to run on biofuel, and that's a disadvantage. Let's look at the combustion of ethanol. So if ethanol is to be used as a biofuel, then when we burn ethanol, it's got to be able to release energy. So let's look at the equation for the combustion of ethanol, the burning of ethanol in oxygen. So ethanol burns, reacts with oxygen to produce carbon dioxide and water and a load of energy. And this process is called complete combustion. Let's start by looking at our equation, which is not balanced. I've written the formula of ethanol, which is CH3CH2OH plus O2 goes to CO2 plus H2O. And that represents complete combustion because our products are carbon dioxide and water. You might choose to write ethanol out as C2H5OH. Now what I want you to do is to try to balance this equation and see if you can work out what the numbers are. And you might wish to pause the presentation at this point. So let me run you through it. If on a piece of paper you write down what you've got on the screen. In a combustion equation, to balance it, you always start by balancing the carbons, then the hydrogens, and then oxygen. So let's do this. Let's start by balancing the carbons. 2 carbons on the left. There's 1 in the form of CO2, so we need a 2 in front of CO2. We then look at the number of hydrogens. And we note that there are 6 hydrogens on the left, and there are 2 in the form of water on the right. So to get 2 to 6, we put a 3 in front of the H2O. So we've now got 2 CO2 and 3 H2O. Count the total number of oxygens on the right hand side. Well, the 2 in front of CO2 times the 2 already in a carbon dioxide molecule. So 2 times 2 gives us 4. And we've got a 3 in front of water. And 1 water molecule has 1 oxygen. We've got 3 water molecules. That's 3 oxygens. So 4 plus 3 gives us 7. Now it would make sense that for us to put 3.5 in front of the O2 because 3.5 gives us 7. But that would be wrong. Look carefully at the left hand side and we can see that ethanol already has an oxygen atom in it. It has one oxygen atom in it. Therefore, we only need 6 more. So 7 on the right, we've got 1 already. And something times 2 gives me 6, which is 3. So it's 3 O2, 2 CO2, and 3 H2O. And this is just a combustion of ethanol. In the exam, they might give you another alcohol, propan-1-ol, butan-1-ol, and expect you to write the combustion equation. It's exactly the same. The formula will be different of the alcohol. Plus O2 gives you CO2 and H2O, and just make sure you can balance the equation. So when ethanol burns or gets combusted, it releases energy, and that's the energy which we use. One of the problems with combusting or burning ethanol is it produces carbon dioxide. And we know carbon dioxide is a problem because it's a greenhouse gas and it leads to global warming. So here's just a quick slide of just some cars which run on biofuel. So fuel which is made from renewable sources such as plants. And we know that ethanol made from fermentation, or ethanol which is produced by fermentation, comes from plants which are renewable and it's considered to be a biofuel. And ethanol produced by the hydration of ethene comes from crude oil, which is non-renewable and therefore it is not a biofuel. An E85, which is an example of a biofuel we've spoken about, is made by mixing 85% ethanol with 15% petrol. But the problem is the car engines need to be modified, making it an expensive process. So let's talk about this term carbon neutral, which is very, very important, and what actually it is. And what we say is that ethanol from fermentation is carbon neutral. And this is the definition of carbon neutral, which is quite big. And I'll give you another definition in a minute, which is a lot shorter and easier to remember and works perfectly well in the exam. So the definition of carbon neutral is the carbon dioxide released when the fuel, that's ethanol from plants, is burnt is the same as the carbon dioxide taken in from the air by the plant by photosynthesis. So I'll read it again to you. The carbon dioxide released when the fuel, in this case ethanol from plants, is burnt is the same as the carbon dioxide taken in from the air by the plant by photosynthesis. What we're trying to say here is that the carbon dioxide released is the same as the amount of carbon dioxide taken in. And that's what we mean by carbon neutral, i.e. there's no increase in the amount of carbon dioxide that's in the atmosphere. Now, the shorter definition for this, which is something I encourage you to write and remember, is carbon neutral is where there is no net carbon emissions to the atmosphere. Okay, so carbon neutral is where there is no net carbon emissions to the atmosphere. So we know that plants take in carbon dioxide during photosynthesis. And when the plants are converted into a biofuel and are burnt, they release carbon dioxide. So let's think about this. In the case of fermentation, we know that the sugarcane will be taking in carbon dioxide via photosynthesis. And when the sugarcane is converted into ethanol and we burn it, because we've looked at the combustion of ethanol equation, we know that it will produce carbon dioxide. What we also know is since ethanol is considered to be a biofuel, because it's produced from plants, we also know that ethanol is considered to be carbon neutral. And what this means is, or ethanol, that's produced from fermentation is considered to be carbon neutral. And what this means is that the carbon dioxide that's taken in must be equal to the carbon dioxide that's released to the atmosphere. And what we have to do is to prove using a series of equations that this is true. And it can be quite complicated, but once you've seen how it works, it's fairly straightforward to follow the path. So biofuels will make very little contribution to global warming compared to fossil fuels. What we're doing here is a comparison. So if you've got biofuels compared to fossil fuels, the amount of carbon dioxide that's been released will be a lot less, and therefore it will have a smaller contribution to global warming. So by showing a series of equations, we can prove that ethanol is carbon neutral. And this has come up in at least 2 exam papers, so make sure you can do this. Now I've used this table because I think it illustrates the process very, very well. And remember, carbon neutral is where the carbon dioxide that's released to the atmosphere is the same as the carbon dioxide taken in. And therefore there is no net carbon emissions to the atmosphere. And we've got to prove that ethanol, which is produced by a fermentation, is carbon neutral. So let's look at the amount of carbon dioxide taken in, and let's look at the amount of carbon dioxide released. If the numbers are the same, then we know that we've proved that ethanol produced by fermentation is carbon neutral. So we know that photosynthesis in plants produces sugars such as glucose. So we know that photosynthesis takes in carbon dioxide. So if we think about our sugarcane, we know that our sugarcane is producing glucose. So photosynthesis in plants produces sugars such as glucose. And we need to be able to write an equation for this. And the equation for the formation of glucose is the following. Plants take in carbon dioxide, they need water, and they will produce glucose and oxygen. So the equation is carbon dioxide plus water gives us glucose and oxygen. And that's what's taking place in the plant. And it makes sense because plants take in carbon dioxide and they give off oxygen, which we need. But for A level, we need to be able to write a balanced symbol equation. Word equations are no use. And see if you can write a balanced symbol equation for this reaction. Okay, so the equation would be CO2 plus H2O gives us C6H12O6 plus O2, where C6H12O6 is the formula for glucose. When it comes to balancing this equation, it's fairly easy to balance. It's a 6 in front of everything. And again, write the equation on a piece of paper and then start to balance it. Balance the carbons first in the form of carbon dioxide, then the water, and then the oxygen. But I'm not going to run through the balancing of this equation. So the equation for photosynthesis is 6CO2 plus 6H2O gives you C6H12O6 plus 6O2. So in terms of the molecules of carbon dioxide taken in by our sugarcane or our plants, it's 6. All we have to do now to prove that ethanol produced by fermentation is carbon neutral is prove that 6 molecules of carbon dioxide is released into the atmosphere. So 6 molecules are taken in from the atmosphere. Let's prove that 6 molecules are released. If you think you can do this, have a go at it on a piece of paper. The first thing we need to do is to write an equation for the formation or the production of ethanol. And we've seen this before. So it's the equation for fermentation. So it's the glucose, which was produced by the plant or the sugarcane, which turns into ethanol and carbon dioxide using yeast. And that's the fermentation equation. So C6H12O6 goes to 2C2H5OH plus 2CO2. We then know that 2 molecules of carbon dioxide are released into the atmosphere. But that's not 6. So we've still got to look at this in a bit more detail. But once we made the ethanol, in order for us to use it as a fuel is a substance which is combusted or burned to release energy. So in order for us to use it as a fuel, we've got to combust it. We've got to extract that energy from it. So let's write the equation for the combustion of ethanol. And again, we saw this a few slides ago. So the equation for the combustion of ethanol is C2H5OH plus 3O2 goes to 2CO2 plus 3H2O. Now, if we look at this equation, again, we can see that 2 molecules of carbon dioxide have been released to the atmosphere. And if you look at equations in terms of the carbon dioxide released, we look at the fermentation and the combustion equation, and we count the total amount of carbon dioxide released, we can see it's 2 in the first process of fermentation and 2 in the second process of combustion. And that equals 4. So again, it doesn't quite balance out. Have a careful look at the fermentation equation and the combustion equation. Now think about the link between those two. Have you seen it? Well, the link is that in fermentation we produce 2 molecules of ethanol. And when we've written the combustion equation, we've only done it for 1 molecule of ethanol. So in fact, we should double up the combustion equation, because since we produce 2 molecules of ethanol by fermentation. If we double up the combustion equation, which we should, since 2 molecules of ethanol are produced, and we should combust 2 molecules of ethanol as well. The equation becomes 2C2H5OH plus 6O2 goes to 4CO2 plus 6H2O. And now if we count up the total amount of carbon dioxide that's released into the atmosphere, there are 2 molecules from the fermentation process, and there are 4 molecules of carbon dioxide from the combustion process, and 2 and 4 equals 6. And there you can see them highlighted in red. Okay, and that proves that 6 molecules of carbon dioxide are taken in from the atmosphere, 6 molecules of carbon dioxide are released to the atmosphere, and ethanol produced by fermentation is considered to be carbon neutral because there are no net carbon emissions to the atmosphere. And make sure you can write these 3 equations in the exam, and make sure you can provide a bit of commentary like I've written. So for instance, photosynthesis in plants produces sugars such as glucose, and write the equation and write 6 molecules of carbon dioxide taken in, and then write the amount of carbon dioxide released into the atmosphere, write the equation for fermentation, right underneath it that 2 molecules of carbon dioxide are produced, then write the equation for the combustion of ethanol, make sure you double it up and write that 4 molecules of carbon dioxide are released to the atmosphere, and then show that 2 and 4 gives you 6 which are released to the atmosphere. So remember, carbon dioxide that's released and taken in is the same, so it's carbon neutral. Okay, let's look at some of the problems with biofuels. So we've spoken about the fact that they're carbon neutral. That's a very, very good thing. But what are some of the problems? Now, as the demand for biofuels increases, so will the demand to grow sugar-rich plants like sugarcane. So if we've got a big demand for biofuels, we also have a big demand for the plants which actually give us the glucose which we can then ferment. This causes problems for developing countries, as it leads to competition for land which is used for growing crops. Land area used to grow crops may also increase deforestation. Okay, so the land area that's used to grow crops may increase, and this will obviously increase deforestation. People want to cut down trees to clear up lots and lots of land so that they can use that land to grow plants, sugar-rich plants such as sugarcane. So not only are they using the land they have available to grow sugar-rich plants so that they can sell on and make a profit for it, they'll also be clearing away huge chunks of forest or trees, making space available so that they can grow it. And that's a bad thing, because we know that trees are very, very good carbon sinks. They're very, very good at absorbing carbon dioxide. So why would we want to get rid of those? This concludes the lesson on biofuels and carbon neutral. Lesson 3 will cover alcohols, aldehydes and ketones.